This video is for section 7.3. Our objectives in this section are to use the product rule to multiply radicals and use factoring and the product rule to simplify radicals. So first we're going to talk about the product rule for radicals, and we're going to illustrate this with an example. So if I have the square root of 25 times the square root of 4, I know that the square root of 25 is 5. I know that the square root of 4 is 2, and 5 times 2 is 10. Now, if I do the square root of 25 times 4 under one radical symbol, one square root bar, I know that 25 times 4 is 100, and the square root of 100 is 10. So I get the same answer, 10, either way. So that tells me that the square root of 25 times the square root of 4 is equal to the square root of 25 times 4. I can combine the two numbers that are multiplied and write them under a single square root symbol. And there's nothing particularly special here about 25 and 4, so I can write in general square root of a times square root of b is equal to square root of a times b. So we're going to look at example 1. It says to multiply. We're only going to do part A here. Square root of 3 times square root of 7. So I can write this as the product under a single square root of 3 times 7. And 3 times 7 is 21. So this is the square root of 21. In this case, the numbers aren't perfect squares, so I'm not going to take the square root here because it doesn't come out evenly. I'm just going to leave my answer like that. So you should do checkpoint number 1, part A. Do this in your notes, check your answer, and then move on with the rest of the video. Next, we're going to talk about simplifying square roots. And so what I want to show you first is what this is going to look like in the homework and what this isn't. So the problems are going to look like this. It says square root of 54, not a perfect square, so it doesn't come out to be a whole number. And it says type an exact answer using radicals as needed. So what they don't want here is they don't want you to type square root of 54 into your calculator. It's going to be 7 point something and type in a decimal into the answer box. That's not what they're looking for. That's an approximation. That's not the exact answer. So what they want you to do here is simplify, and you notice it says using radicals as needed. That means that your answer is going to need to have the square root symbol in it. And to get the square root symbol, when you click on the box, square root symbol is in the middle of this row of buttons along the bottom. So that's how you get that, and then we're going to talk about how you actually get the answer here next. So the process for simplifying square roots. Step 1 is that you find the largest perfect square factor. Or in other words, the largest number that the number can be divided by that is a perfect square. Once you find that, step 2 is that you break the number into two factors. One is going to be the largest perfect square that you found in step 1, and then another number, so that when you multiply the two numbers, you get your original number. And then step 3 is that you're going to simplify the perfect square factor. In other words, take the square root and get a whole number. You'll get a whole number since it is a perfect square. and leave the other factor under the square root. So the other number should be a number that's not a perfect square. If it is a perfect square, then that tells you that your original number itself was a perfect square. And so you can just take the square root of that number on your calculator and it should come out to be a whole number. So what we're going to do next is review what numbers are perfect squares. And it's a good idea to have these written down so that you can refer to them when you're doing these simplifying problems. Either write them in your notes, or what I would recommend is writing them on a separate piece of paper, maybe like just a little index card, so that you can have them to visually look at when you're doing these problems, because that really helps. So I'm going to write these down here. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. I shouldn't need anything higher than that for the problems that we're going to see in this class. So we're going to talk about how we use this next with an example. So this is an example that's in the text on page 527. It says to simplify square root of 300. So what I do is I start with my number 300 and I look at my list of perfect squares and I divide 300 by each perfect square, and I'm trying to find the largest one that divides evenly. So I start with the higher numbers so that I can find the biggest. So 300 divided by 225 doesn't come out evenly. 300 divided by 196 doesn't come out evenly. 300 divided by 169 doesn't come out evenly. 300 divided by 144 doesn't come out evenly. 300 divided by 121 doesn't come out evenly. 300 divided by 100, that does come out evenly. That's 3. So that tells me that what I'm going to use here is that 300 equals 100 times 3. So I'm going to take the square root of 300. I'm going to break 300 up into 100 times 3. And then I'm going to break the square roots up. So this is kind of going backwards of the product rule stuff that we did earlier. Square root of 100 times square root of 3. And then simplify the one that's a perfect square, which I usually am going to try to write first. So square root of 100 is 10. So this is going to be 10 times the square root of 3. And I don't need to write the multiplication symbol in there. I can just write the number 10 in front of the square root of 3 and the multiplication is implied. So next we're going to look at example 2. This is to simplify by factoring. We're only going to do part A, and it's the square root of 75. So when I'm working with smaller numbers, like square root of 75, I don't need to divide by any numbers that are larger than 75, because I know that if I take 75 and divide it by a larger number, it's not going to come out to be a whole number. It's going to come out to be something less than 1, or a fraction. So I don't need to do 75 divided by 225, 196, etc. What I can do is I can find the two numbers that 75 falls between, which is right here. It's between 81 and 64, and I can start there and work my way down. So 75 divided by 64, no. 75 divided by 49, no. 75 divided by 36, no. 75 divided by 25, yes. 75 divided by 25 is 3. So I know 75 equals 3 times 25. So I'm going to write square root of 75 as square root of, write the perfect square first, 25 times 3. Break it up into two square roots, square root of 25 times square root of 3. Square root of 25 is 5, and leave the 3 under the square root symbol, so it's 5 square root of 3. So this is my answer. Traditionally in math, we write the whole number first in front of the square root, and that's so that we don't have any confusion over where the square root bar ends. So if I were to write it this way, then you might not be sure if the 5 should be under the square root bar or not. In this case, it's not supposed to be, but it's possible if I made this a little bit longer, it could be kind of ambiguous. So to avoid this confusion, we just write the whole number in front. Then it's clear that it's not supposed to be under the square root bar. So you should do checkpoint problem number 2, part A, the square root of 80. Do this in your notes, check your answer, and then move on to the homework.